All right, we're going to do numbers 5, 6, 7, and 8 from your Geometry Chapter 3 self-test in this video. So I'm going to start with number 5. And in number 5, it says in the diagram below, the ray PS bisects angle APB. And the measure of angle APS is 4Q plus 8, and the measure of angle BPS is 2Q plus 18. And we want to find the measure of angle APB. So a lot of geometry lingo there. We'll kind of break it down here. We're going to start with this. Angle PS bisects angle APB. And angle APB is this angle right here. I'm kind of outlining. This is angle APB, or it's this angle measure right here, whatever this is. That's APB. And PS bisects it. And what bisect means is to cut it into two equal pieces. So this angle right here and this angle right here are the same. So APS and BPS are exactly the same measure, and we know that because we are told that this ray bisects this entire angle APB right here. And we have algebraic expressions representing those angles. So what I can say here then is 4Q plus 8 is equal to 2Q plus 18, because I know that APS and BPS are the same measure because of this bisecting ray here, PS. So I can say that those two are equal. And now we have an algebraic equation to solve. When I look at this, what I'm going to do first is I'm going to subtract 2Q on each side. And if I subtract 2Q from the right-hand side, this 2Q goes away. And I come over here and I subtract 2Q from 4Q, and I get 2Q. So I have 2Q plus 8 equals 18. Next thing I'm going to do is subtract 8 on both sides. To get rid of this plus 8, I'm going to subtract 8. So 2Q will equal 10. The 2Q is right here. The 8 is gone because we subtracted it. And this 18 becomes a 10 because we subtracted 8. 2Q equals 10, divide by 2 on both sides, and we get Q equals 5. So we're not done. It might seem like we're done, but we're not done. We just know that the value of Q is equal to 5. And we want to find the measure of the whole angle here, APB. Basically, both these angles put together. So what I'm going to do is I'm going to take that Q, and I'm going to plug it in, or take the 5 and plug it in for Q in this angle right here is what I've done. 4Q plus 8, 4Q plus 8, but I know that Q is 5, so I plugged in 5. 4 times 5 plus 8 is 20 plus 8, so therefore 28 is the measure of APS. I don't want to know the measure of APS, I want to know the measure of APB. And I have this angle right here. I know that this angle right here is 28 degrees. And I have to find this angle. But I know that they are the same because this was the bisector. So if this angle is 28 degrees, this angle is 28 degrees also. So if we multiply that by 2, we get 56. And the measure of APB will then be 56 degrees. Number 6. Angle 1 and angle 2 form a linear pair. We talked about that earlier. The measure of angle 1 is 12 more than 5 times the measure of angle 2, and we want to find angle 2. So kind of a lot of information there. That might be kind of hard to sort out, but we don't know a couple things. I'm going to call angle 2 x. I don't know how big angle 2 is, so I'm going to call it x. I don't know how big angle 1 is either, but I'm going to call angle 2x. If I know angle 2, I know the relationship between angle 1 and angle 2. Angle 2 is x, and I know that angle 1 is 12 more than 5 times angle 2. So if I take angle 2 and I multiply angle 2 by 5 and then add 12, I get angle 1. So x is our value of angle 2, and then 5 times angle 2 plus 12 is angle 1, and we know that because it says that right here. Angle 1 is 12 more than 5 times angle 2, and that's exactly what this expression is saying here. What do we do with these things? We got to find angle 2. Well, we know they form a linear pair, and we know that a linear pair adds up to 180 degrees. So I'm going to take angle 1, 5x plus 12, add it to angle 2, and that should equal 180, or it does equal 180. Combine like terms, and we get 6x plus 12 equals 180. Basic algebra here, subtract 12 on both sides, and you get 6x equals 180. And if 6x equals 180, then x equals 28 from dividing by 6 on both sides. So we have x is 28. What does x represent again? Oh, x represents angle 2. And we want to find the measure of angle 2. So we have just done it. So angle 2 is 28 degrees. Number 7 and 8, we're going to state the algebraic property that justifies the statement. We have the distance between P and Q is equal to the distance between R and S. That's what this means here. If there's no symbol above this, it just means the distance from point P to point Q. So this distance from these 2 points is the same as the distance from R and S. And S to R, and RS and SR are the same thing. If you go from R to S, it's the same as going from S to R. The distance is exactly the same. And that distance is equal to the distance from M to N. So the conclusion is PQ is the same distance as M to N. How do we know that? Well, there's this transitive property. If A is equal to B and B is equal to C, then A and C must be the same. So we kind of transfer this value of A to B and then B to C, so we can conclude then that A and C are the same. That's exactly what's happening here. The intermediate here is the distance RS, because PQ is the same as RS, and so is MN. So if these things are both equal to the distance from R to S, then they must be equal to each other. So the answer to this question would be the transitive property. And number 8, we have another kind of confusing geometrical algebraic equation here. We have the measure of angle ABC is equal to some angle EBF. So these 2 angles are the same. And this implies that if we add some new angle, CBE, to ABC, and we also add CBE to EBF, that they're still the same. That ABC plus CBE is the same thing as EBF plus CBE. So all we've done is we've added in this CBE angle to both of them, and they're still the same. And what says that those 2 things are still the same are the addition property of equality. If you have something that is equal to it, to another thing, and you add the same thing to both sides of that equation, then they remain the same value. And in this case, we're starting with this A and this B, and we're adding on this C, which we're calling angle CBE, here and here. And if we add those to both sides of that equation, these values will still be equal. They're not going to be the same as what they were here, but they will still be equal to each other. So this would be the addition property of equality.